Okay. This is video 157. It is part 84 of my PAINT5D sprint, which is not much of a sprint anymore. And, let's get to it. So, we have a lot of things we need to do. Well, not a lot, but, well, they're relatively big tasks. So, I got to refactor some of the silencing code for all of the systems. Then the tau-type bounds checking fixes. Like, I think it might already be fixed, but I want to make sure I have all the logging systems refactored here before I address this anymore. And then we have some mouse wheel code after that, which is what I was working on mouse wheel code already, but now we just found some issues that we probably need to work our way on. So frag bed is the first thing we want to work on this list. So if we look for frag bed right here, right, it's right here in the list. So let's highlight it so we can focus on it here. So frag bed, and so let's close. Well, actually, let's take some time to reload our shortcuts because I believe we have shortcuts for all of these things. But we made them yesterday. And, yeah, we made them yesterday, and we haven't reloaded our shortcuts since. So we're going to reload our script, and it's going to take some time, and we're going to try to refactor to the best of our ability while we're doing that. So we've already made a mistake somewhere. Okay. Okay, so let's just kind of go through the things and try to do this manually and hope that it's not too hard. So, Fragbed, where are you? Okay, this may take a while. Go live dodged. Yeah, so I have to edit some of my shortcuts. Okay. Okay, I think that's good. I mean, I'm sure there's plenty of other things I need to fix, but it needs to get done. I used to reload my shortcuts, like, all the time, like, multiple times per day. But now the file has just gotten so large that it's not efficient to be reloading this all the time, because this is going to take, like, 10-15 minutes. Just for those to reload, and we'll try to get some work done as that's happening. So we're still doing different kinds of info messages here. And we're going to try to just refactor this with the info any function, right? So if we go into, hold on, F, Lego house. We're going to move everything that's Lego house, we're going to move it up to the top. And So just editing my shortcuts. This may take a little bit. Lego houses. I'll steal that. Okay. Okay, change that around. And yeah, it just takes some time to refactor things. Yeah, so let's go find an example of something we can steal from maybe an older system. Or not an older system, but a newer system. So like PAINT5D. PAINT5D should be one of those systems that is new enough. Well, I mean, maybe not, because we worked in a lot of other systems that we've inserted before PAINT5D, so that may not be the case, but let's see if we have kind of like the, well, hold on. We actually want this function, log after halt. Let's just steal this from over here and use it in our code, right? So what we want to do here is we just want to we want to refactor this code a little bit so that this generic logger function kind of like handles all of this stuff down here. And then eventually we might want to like refactor some of this stuff out of here. But for now, we're stuck with it as it is for now. We just have to wrap it. Okay, so AAC, this is frag bed, right? So we're going to look for the lowers and the uppers and refactor them. So these two lower ones, frag bed, and this upper one, frag bed. Okay. Then after we have this info any message kind of made, we can go into here, where we're kind of like, we see these wrappers we have. These wrappers for the silence system are out of date. So we're just going to really, we should probably have passed ourselves into a function. Whatever, let's not worry about it now. Let's just get it working, even though it may be a little bit more obtuse than we wanted it to be. So, this thing right here, frag bed info. Uh-huh. So in the future, try Okay, so so in my mind, there's only two kinds of logging messages. There's logging messages that you do before you crash, and then there's logging messages for something that's non-fatal. And so in the future, I want to try to only use this. But right now, we're just going to refactor to get things working, and so some of the things are just going to be ugly. And that's just the way it's going to be. So this info any function, okay, yeah, why don't we do that? Okay, I'm just trying to figure this out. We're gonna do... So we're gonna printf, and then we're gonna flush. Let's just put that on one line. We're gonna printf and flush. And then after we've done that, we're going to call this do we really want to do that? No, let's not do that. Yeah, let's just do this. Let's hackishly kind of fix this and just say... Right, it's just an info message. It doesn't have anything after it. It's just the info message. Info message is still const char, that's fine. So let's just remove some of this code, right? So this extra flush thing we don't gotta worry about because the extra flush is over here, right? So then over here, we'll just do the same thing. So we're gonna just say, right, and then we're gonna do strfmt. Format string is, that's kind of backwards, but okay. str, oh no, you got it. Because the first thing is the format string, right? Format string and then some type of data, got it, okay. Got it, strfmt. And then we need a void pointer for the other one, right? So we need a void pointer cast of strmsg, right? So right here we have to discard the const char qualifier on that piece of data. That's why this needs a void pointer cast. And so we'll just do that. Define VP as void pointer. Well, if we're going to use a cast like that, we can't wrap it like that. Void pointer cast. Right, so this is a void pointer cast here. I don't feel like deleting some of these macros I already have, so I'm not. So down at the end of this, we need a VP for void pointer cast down here. So undef VP. That sounds like my shortcuts are reloaded. not too many collisions. Sometimes I have more than others. It really depends on the luck of the draw of what I was looking up before I made my shortcuts. Okay. So yeah, so we got this info any message, and we're gonna keep on doing this. And I really don't care, like, what style of message it is. Yeah, I really don't care. So yeah, we're gonna keep on doing the same thing over here. So we're just gonna say this, and then strfmt, and then void pointer cast for des msg, right? And this one was string message, this one is des message, and then over here, same deal, right? So we're getting rid of some lines of code, so that's cool. strfmt, and then void pointer is chr msg, right? So care message. Okay, cool. So a little bit better than we were, and we also, by doing that, we have made our logging all rely on this, and this logging has the correct logic to make sure we don't that we don't we want the right the main flag for this system for logging, and then the overrides, right? So two overrides, one to shut everything off, and another one to turn everything on, and then one to turn everything off, right? And then so off by default, see if we should be turned on because the flag says to turn on, and then because technically, if we wanted to keep things symmetrical, we could have this. We could. No, that's fine. Okay, so we're gonna make sure this still runs. Right. So we did a whole bunch of refactoring. We want to make sure that that's not what I wanted to do. We want to make sure. We want to make sure that still compiles and still runs. And if that's the case, we're going to keep on going through the other systems and fixing everything else. From integer of different sizes. Okay, yeah. So we need a int pointer. Or a not int pointer. So we got unsigned U32, we got okay. So we need so up, right? Unsigned int pointer, right? Unsigned, I'm gonna make a note of that. Unsigned int pointer. Define uint pointer. So I have a lot of options here that keep on popping. Define uint pointer. Define unsigned int pointer. Define up. How about that? And then in here, we're going to just steal what we just saw. So this uint pointer max thing here, that's pretty useful to me. So I think we just had to define UP to get that. So we're going to go take this and look for define UP for a second. Define UP. Define up. Right, define UP. Unsigned int pointer and int pointer, right? And we're gonna go use that for this right here. Paste file. So next time we have that for next time. Okay, so yeah, this uint pointer type we kind of need, and so let's just put it in here, 04, make this 05. It's just because of my compilation settings and how strict I'm being. So this is our uint pointer. Alright, so uint pointer right here. Uint max. Maybe you want to adjust that spacing a little bit. And when we're doing our casting to a void pointer, before you can just cast from one size to another, a void pointer is on a 64-bit machine is, well, 64 bits wide. Whereas integers and chars and probably even this U32, well, U32 obviously, they're all 32 bits, right? So we can't cast directly from 32 bits to a void pointer. I am not allowed to do that with my settings. It's to help catch mistakes. So we're gonna say we're gonna cast it to a uint pointer, and it doesn't matter if it's assigned or it's unsigned. We're always gonna cast to a uint pointer, just because, well, let me think about that. Yeah, we're just gonna cast a, well, actually, no, it shouldn't really matter, let me think about it. Well, the actual data could be... Okay, we might want to cast this to assigned integer pointer, since the decimal message is... Oh, this is already a U32. Never mind. Uint pointer. So I just don't want the data to be destroyed. Char is signed by default, I believe, right? Char can be negative. So maybe if we want to be careful, int pointer. Because I'm worried about sign extension. We're probably going to get that no matter what, right? Okay, and then char, also int pointer, not a uint pointer. Okay. So I don't know what's going to happen here. I'm just going to hope that, you know, all of my mucking around hasn't totally broken things. So let's just make let's define int pointer here. So define IP, right? Int pointer. And it's obviously something I've done before, that's why I have a macro for it. Right. So UIP. So UIP. So right here, undef int pointer. Alright, we're doing good here. And 05, and then this one's going to be 06. So we got 6 different things. Okay. Okay, cool. So let's give that a run, see if we have subverted the compiler, and then we'll just go from there. Okay, now we have fragbed logging. Let's go fix that really quick. Not on disk. Yes on disk. Yeah, let's go change this logging message. So, for whatever reason, we have, if we're using a log message, we don't want a new line in here. And not on disk. For the yes on disk, we want to make these a little bit more different. So for the yes, we're going to say it's more important that I know that a file is not on disk rather than yes it is. So I'm going to make this lowercase, yes on disk. And I'm going to change this a bit. So I'm going to keep the other thing. I'm going to keep this original message for here for reference. But then what I want is just to write this a little bit different, where I remove some of the letters. Just so that it looks different, right? So that when I'm looking at this cluster of things, I want to be able to see things a little bit clearer. So let's give that another shot and see what we got here. And the idea is just to condense that summary, get rid of those new lines, and make it look a little less ugly. Okay. So that's a little bit better, right? So fragbed log, right? And then we see, for this, we see file not on disk, this one, because we decided to delete it using our build system. I thought we also deleted one of the other shaders as well. Maybe not. But anyways, yeah, we can see yes, disk, and we have these things here. So file not on disk, and then yes, these are on disk, right? So yes, disk is kind of like a weirder kind of phrase where it's like, what the heck does that mean? But it's just so that when we see a peppering of file not on disk and yes, disk, these phrases look more different. So when I'm looking at a table of what is on disk and what's not on disk, I can read it a little bit easier. And also, this is the more verbose one because not on disk seems like something I would be more concerned with than if it's on disk, I think. And that's subjective, but okay. So yeah, that is working. We're still getting this error, and we just want to, before we address that, we just want to go through all the logging and fix it up. So that's good there. Let's go on to the next thing. So it looks like pixel save is the next thing. So let's go file, open, and look at pixsave and see see what kind of stuff we got to do for this, right? So in the lib folder, we got pixsave and the functions, and it looks like log after halt, info any. So we got the more modern way of doing this, so this is going to be a lot easier because we can go in here, and actually we can use our shortcut now, right? We can go log after halt info any paste, right? And then we have these things here we gotta replace. And yeah, so we're in PicSave, so we're just gonna call this PicSave info any. This one's uppercase. This one's lowercase. Okay. And that should be all we need to do for that. Less work than the other ones, just because the newer code kind of conforms to the way we've decided things should be done. Okay. So now, nothing crashed, so on to the next thing. We want pixel backup. So let's go look at that, right? So go into, let's close these, right? And fix back. Okay, in pixel back, we have another log after halt function. So once again, we can just say this and go info any paste, and then we will once again put the correct things in here, right? So this is in pixback, so this will be pixback. This right here is pixback, all capital, and then down here is lowercase, pixback. Okay. Alright, that should be good for there. Let's just keep on going until we get to the next thing, right? So GPU data, let's go look at that. So this should be a lot easier. I think that we're getting to the point where I said that, and now we're like here, and it's like, So this is... Okay, so this is also older code. So we're just going to say goals are never errors, neither are OK messages. So we're just going to go right in here. We're going to say, we're going to do info any paste, and we're going to shove our new logging message in here. And, or maybe we're not, because we have this, like, goal message and blah, blah, blah stuff. The cat... God damn it. Alright, well, I guess we'll have to change it around a little bit. I see somebody is in here. I don't know if you're new or who's here, but, you can always check out my technical demos. Let's actually see what we got, users in chat. Anyone that I recognize? I don't know who is here, but, oh, okay, Luncho, hey, how's it going? Yeah, so I'm just doing some refactoring where, as I was doing the mouse wheel stuff, some old code failed a unit test, basically, and, well, it didn't directly fail a unit test. Old code inside of a unit test triggered a runtime assertion, and I didn't know where that runtime assertion was coming from, and so I needed to turn on, like, all of the logging for all of the subsystems to figure out very quickly where everything was coming from. And so now I have to make a master override for my logging. So basically, let me show you my logging system really quick, and then I'll get back to it. So, this is the logging system over here. And we have a flag for every single system for whether or not logging is on or off. But then we have a master switch right here called silence. And if silence is negative, then it's an override that turns logging off for everything. And then, sorry, I got that. I really shouldn't have called it silence because I have to think about it all inverted-ish. If silence is negative, it's like super off. It's like super false. So that means nothing is silenced. That means logging for everything is on. And then if the silence is positive, that's like our super true value, which turns, it if silence is positive, that's the override to make all of the logging shut off, right? So I'm having a hard time wrapping my head around this because I really shouldn't have named it silence. I should have named it yell instead. But whatever. Because the bits are all kind of like the opposite of what I would naturally. You think about 1 for true, and you think 0 for false, right? But because I called the system silence, and if it's 1, things are silenced, that bit logic is all reversed on me, and shouldn't have done it, but too late. That's what I got. But yeah, so silence, if it's 0, it doesn't do anything. If it's 1, it's a override in one direction, and then if it's 0, if it's negative, it's an override in the other direction, right? So it's just an override flag that will turn logging all on or turn logging all off. So if the idea is that I don't want to have logging messages for all of this stuff all the time, usually I want to focus on very specific logging messages. So I have very specific systems that I'm concerned about at the moment, where logging is on, and then certain systems where I'm not concerned until logging is off, right? And then you'll see the on flag is 0, and the off flag is 1, right? Because if silence is 1, then the thing is silenced, right? And therefore logging is off, right? So these flags, that's why I made these little macros for off and on, because the logic is all inverty, and yeah, it's I regret the decision, but this is just the way it is now. But yeah, so right now we have all this logging, and what we don't want to have to do is like this state is kind of important to us, right? So if we want to turn logging all on, we could just go here and we could just column select all this, and we could type on for everything, and boom, we'd have logging on for everything. But then we would lose that state we have, because this state is kind of important to me as I'm working on the project, right? So, but every once in a while, I just want to turn all the logging on or all the logging off, but usually I want to keep track of this state. So in order to not lose any of this state, I don't want to manually just turn everything on here. I want to have an override right here that's going to do that for me. So that's kind of what I'm doing. So it's kind of pretty mundane kind of stuff. And then it's easier to refactor in some systems than it is other. I see somebody else popped in. So I knew that chat erases if you are just in the chat room. So technical demos, there you go. Okay, so anyways, this GPU data looks like it's older code just because of the way I did my logging messages. At one point, I had different logging messages, right? Like, here's a goal message, here's an OK message, and I have this proliferation of logging messages, and it got out of control. And now what I realize is there's only 2 kind of message functions I need. I need a halt function that gives me a message when I crash, and then I need another type of logging message that just doesn't crash, right? So I basically need a non-fatal logging message and then a fatal logging message. You could think of it like that. And so there's really only 2 things I need. So the goal with that is to reduce the granularity of the code, right? This got way too granular, and we want to avoid that kind of granularity in our code, because very granular code is just very hard to... It's hard to manage, it's hard to refactor, it's hard to wrap your head around. So we want to keep our code as coarse-grained as our logic will permit. Okay, so now that I'm done ranting, we're going to have to make some macros to shorten our column limits here. So we're just going to like define ff as flush, fflush, std out. Alright, and then down here we'll undef it. And that might be all I need in order to... Well, probably not. There's probably some more things. But, so, right here, we're just going to be like, bam, right there, fflush, and then this is also fflush, std out. And we have this over here, which still needs attention, so, I don't know. I guess what we could do is, We could either look at this, or we could change this to, well, let's address this first. So this needs to be GPU data, right? Private namespace, public namespace right here, GPU data, and then private namespace over here. And you may be asking, why don't I just use a template? Well, first of all, this is C code. Second of all, I just haven't, I could make some, you know, bash script preprocessor stuff to auto-generate some of this stuff, since it's all very similar, and that might be a good idea in the future. But the other thing is that I want my code lacking in abstraction. So a lot of people want abstract code that is fluid and easy to refactor, and that's not actually what I want. I want code that is very clear, right? So hard coding this function that is pretty much very much similar in all the other classes or all other libraries. Hard coding it like this and having to painstakingly refactor it is a pain, and it's very slow, and it's not a flexible way to do things. It's a very rigid way of doing things. But my main concern is that I want people who are reading the code, to be able to understand what's going on. And if we make a fancy build system to like make this into a template or to auto-generate this code, we're making the project harder to understand. So I am doing things in kind of a harder, slower way to do things, which is more rigid and less flexible, just because I want the code to be easily understood by other people. So that is why I'm doing some things in a very obtuse manner. So let's just define, to shorten this line, let's try to shorten it with minimal mental indirection. So what I mean by minimal mental indirection is we can call this, will that work out for us? That might not. Never mind, we're not going to be able to do that. How about, oh, you just call it logging system? Right, so basically it's a logging system, right? So I want some, when I say minimum mental indirection, what I mean is that there's obviously 1 degree of indirection here, right? Because we go from here to here, right? So that's 1 degree of indirection, but the mental indirection doesn't have to be the same magnitude as the actual indirection, right? So log, sys, and silence, it's not the same amount of mental indirection because we know that this is the logging system, right? So when we're looking at this, we go log sys, where you don't have to, the easier it is to remember what this macro stands for, what it resolves to, the less mental indirection we have, if that makes any sense. And I'm just making up words here, like, I don't know if there's already an established, like, scientific word for mental indirection versus actual indirection, but so that's just the concept that I use here. So with that, we have everything kind of shortened so that it all kind of fits in here nicely, right? We just want things to fit in our call limit because, because why? I don't know. We could make up a justification for it besides us being just very OCD. Well, there is actually a justification for this call limit. So besides the fact that, yeah, I can split screen this and you can see it on the stream, besides that, the other advantage is I can just scroll up and down, and I never have to scroll left and right? So I can seek through the code very easily when nothing goes over my column limit. Also, in diffs, if you're looking in diffs, you don't have any, like, mystery code going off the line. You don't have any, what do you call it? Soft wrapping issues, none of that stuff. So, okay, so let's let's make sure this still works, right? Before we go any further, let's still make sure that still compiles to this point. And then we're going to okay, so still at this error. So yeah, we're still good. Or at least I think so, yeah. Because logging for everything is turned on, so... Okay, so Pixel Pusher is the next thing. So let's go look at Pixel Push. Okay, halt is typically the first function. Okay, message for poor man's debugging. About to error message. And the about to error message should never be turned off, right? So... Right, so this has is using the silent. Is anything else using the silent system here? No, it's just that. So we're just going to change this around so that this is just going to be a wrapper for this about to error, not about to error. This message here is just going to be a wrapper now, right? So this message here right is just going to be a wrapper for. Right, so we're going to do info any. We might want to actually pix push, info any, and then just OK message, no new line, and then MSG OK is a const char, and it needs to be a void pointer in order to get in here. So we'll just do void pointer. Void pointer cast before we call it. Yes, just make this a wrapper for the info any function up here. And then also, you know, make sure we got this, right? So this is going to be info any, or goddamn no, pix push. Then over here it's going to be pix push all capital. And then over here is pix push all lowercase. So pix push all lowercase. Okay. And that's all we need for that refactor. Let's make sure that this still compiles. Make sure we haven't made any stupid mistakes. Okay. So eventually this fixing thing that's saying it's a fatal error, we may just remove this message, right? But I just wanted to know that that fix was being invoked before I, invoked by some code before I, the code that is, I edited my rectangle bounds enforcement code to do some other behaviors because it wasn't working in the most proper fashion, but that could have some consequences on my unit test, so I wanted to know that that was happening. That's why this message is crashing right here. And I'm going to address that, but after I do all the logging stuff. So pix push is done. So dump assets right here is the next thing we got to look at. So and hopefully this is new enough to where, yeah, info any, right? Yeah, so this is good here. So, we can do info any paste, right? Log after halt. And this is going to be an easier one because it's more conforming code to our newer way of doing things. So we are in dump ass, right? So dump ass for dump assets. This is the uppercase, so this is dump ass for uppercase, and then this is dump ass. Okay. And let's go on to... Let's try to get more taken care of at the same time. Because we've been... So far, we haven't been making any refactoring mistakes here. So let's keep on going until we get to something that is not conforming to the new way of doing things. So let's do info any paste. And we'll just go through here. And for this, we have... we're in GentCom. And that's for generate tile common code. Generate tile common code. Okay, so we did the common code right here. Now I want to go gent DAO, so let's go in gent DAO now. And log after halt. So right here, we're going to do info any paste. And we're going to substitute these. So this is gent DAO. So gent DAO for generate tile down, right? So we're taking a big image and we're downsizing it into the different memory subsections in order to auto-generate a tile design. So gent DAO and gent up are the different main strategies I was thinking of using for generating tile data. I did not finish them completely because I decided it was a relatively fruitless effort. Where it's better just to have the artist make some interesting data than to try to use simple algorithms to... Rather than trying to make simple algorithms to do it for us, it's really just a better idea to have an artist do it because garbage in, garbage out. So you take some random garbage data and try to transform it into something interesting, chances are you're going to be disappointed. So get a good artist who knows what they're doing. Okay, so... Okay. So this is gent DAO or gent up? Gent up. Oops. Gent up. This over here is uppercase, so this is gent up. And this down here is lowercase, so this is gent up. Okay. That's good. PolyOGL has a question mark on it, so let's go look at that and figure out why that is. It might just not have any logging function, so halt is typically the first function, and then do not paste. Yeah, there's no logging stuff in here. Yeah, there's no logging. It does not... So this question mark can kind of be resolved. I don't know, read the code, right? So the answer to this is doesn't talk, right? So change that to a star. And now let's go look at fragcom. I actually think that's wrong. Oh, no, it's because there's unit tests. Fragcom has unit tests, and that is why there are logging functions in here. The fragcom.fra for fragment shader is where the actual fragment code is. So yeah, right here, we're going to do info any paste. And we're going to address these two. So fragcom, and then right here is going to be called fragcom, uppercase, and then this is fragcom lowercase. Okay. And now GPU wire up. Let's go take a look at GPU wire up. Okay, so we got a halt function, we got a log function. So right here, we're going to do... Paste that in there. And we want to take care of these two things here. So this is GPU wire. So GPU wire, uppercase GPU wire, and then this is lowercase GPU wire. Okay. And now I want to look at GPU view. So let's look at this. GPU wire. Texture memory wire up utils to be used by the different editor subsystems. And I don't think we have any code in here yet. But our intention is to eventually refactor stuff so that we have that, right? And then GPU view. So the next time we make another system and we have to wire it up, we're going to address the GPU wire. Okay. So GPU, let's go this. Info any paste. Yeah, we're going to correct this, and we're going to correct this. So GPU view, right? Because we're inside of GPU view. GPU view. And then right here's GPU view as well. All lowercase. TauDirt. Let's go look at TauDirt and figure out why it has a star. So it's saying that TauDirt doesn't have any logging now. Is that true? Or did we make that up? So let's go look at that. Sure looks to me that that it does in fact have stuff, right? Because it says doesn't talk here, but we see right here we see an info any function, right? So that looks like a lie. And not only is there info any function, but it looks like it is being utilized. So I don't know if that's because we added this after the fact. So we're just going to say info any paste. It's a good thing that we actually opened this up and looked at it. Now I'm kind of curious as to whether we screwed stuff up over there as well. Let's not worry about it too much. If we want to get logging function from one of these things in the future, that's the time that we'll actually open it up and add logging code and see if it's there already, right? So right here is TauDirt, right? So TauDirt for texture as memory dirty flags. Okay. So that's good. And that also means that my little diagram here, logging code has been added. This is already addressed. And Tau Depot is the next thing we want. So let's go look at Tau Depot. Okay, so we got a little... The most important functions are up at the top in comments. I'm keeping it that way. That's just very helpful, because that's what I usually use when I'm looking at this. Logging and halting. We got Tau Depot info any, and we got Tau Depot halt. So let's just... So this is nice, where we have these sections here, but, this isn't how we do it, right? So, halt is, so, it has all of the correct, and then, so we're just going to get rid of these functions here. And I do like, logging and halting is not like a bad categorization of what's going on here. Like, I don't mind that. Just the problem with that is that, my column limit suffers from that, right? We can... We could do this. We could say, Um, I don't know if I like that, but sure, let's try that. So define log sys, define all, and then that's not supposed to be define. The logging system is this, right? Everything is represented by this flag, right? It's an all override, right? And then me is for the specific Tau depot system, right? So what I'm saying is we can go in here and we can just replace this with log sys. And if we do that, Tau depot, and then over here this is Tau depot as well. If we do that, we already hit our column limit, right? We don't need to do any more, do we? Except for this. So I'm thinking just calling it log sys, and then right, let's not do all this, right? Let's just define log sys and define flush f, right? So f flush std out, right? And then right here I can just go ff and then here undef. So log sys, right? So that's kind of like, right, if we want to keep logging and halting in the same section like that, I'm not completely against that. So, I mean, that is not a bad idea, honestly. But if we do that, I want it to not go over the column limit, and we're adding an extra level of indentation. We're adding an extra level of indentation if we make the decision to categorize, group these two functions together, right? So there's no syntactically enforced indentation. Well, I guess no indentation is enforced, right? However, this is still not quite right. So I feel like this would have to be like a printf, and then we're just within the bounds of what we need. So if we're going to do that, we might as well do it over here as well. So printf, right? So define pf as printf. And usually my macros are just replacements, like word replacements. I try not to make my macros any more fancy than just simple find replace. Because if we don't make them find replaces, it can make it really hard to find stuff in the future. So okay, so now that we have that, this halt function is Tau depot. Tau depot halt. F flush std out, and this is not going to be this. This is going to be like, I don't know, 106. I don't care. Or actually, well, what's the current system number? I don't even know that. Let's not worry about that. I guess we could do that, right? From now on, if you wanted to. But I don't really want to maintain that, right? But at the moment of writing this, you know, Tau depot, if we look at Tau depot, it's system number 39, right? So we could say 39 to say it's an error from system 39, right? Like, maybe that's cool, maybe that's helpful, I don't know. But yeah, let's make sure this still runs, because we've been mucking around a little bit more than usual, right? So, since we've been mucking around a little bit more than usual, we want to make sure this still compiles correctly. There's no syntax errors before we continue. Okay, so still compiling, we're good. So this was tau depot. So now we want to look at tau type. Okay, so we got this info any message, and we can see that it hasn't been completely refactored yet, but it's conforming to how I like to do things already. So info any paste, so it's going to be easier refactor than the other refactors. And then this I'm actually going to want to run right after I refactor it, because that's the message that's currently crashing. Oh, actually it isn't. Well, actually, this will tell me if I'm entering a unit test or not. So, tau type has a unit test that it's entering currently. Tau type, and then tau type. So I want to be able to see that. I want to be able to see that so that, right, so right here it says tau type log. I want to make sure that these tau type logs are still showing up, right? Because if they're not, that means I've done a whole bunch of refactoring already, and I've completely screwed over myself with how I've written all the code I've been pasting. So, cross fingers that I have double-checked this and that it is correct. Yes. Okay, cool. So, we can still see the tau type logs right here, coming from the info any message, right? These logs come from the info any, and that's good. That's good for me. So we can keep on going. Let's keep on going here. So clear this, look at our list of things we got to do. This is done. So now we have 3 more left. So let's go look at tau sync. Tau depot, tau dirt, tau sync. Okay, so this info any function looks like log is after halt. And we have like this info dec and holy crap. Oh, okay, so it looks like we already did some refactoring, right? So this info decimal is just a wrapper for the info any function, because we saw the errors of our ways. So we'll go in here and we'll say, oh, hey, how's it? I don't know, man. Because I'm the one talking. Probably because I'm the one. Oh god, 34. So I am not actually doing anything interesting today. Well, I could try to get it up and running for you if you want to see. Okay, sounds good. Thank you. So actually, let me get this up and running. Hey, how's it going? I don't know how to. There's too many vowels in there for me to be able to pronounce it. I'm sorry. I'm bad at spelling. I got like E's, like F's in English, and then A's in math and science. So I can't pronounce stuff worth anything. No worries. Yeah, thank you. Okay. So let me just try to get this working for a second. Info any. I am doing some really basic kind of refactoring right now. Let me explain what I'm doing right now. Okay, so I have this big system here called silence, right? And this is a big list, like over here on this side of my screen. This is a big list of all of the different systems in the game. And I can turn logging on or off for these systems, right? So logging is off for these systems, and then logging is on for these systems. But there's, at some points in time, I want to turn the logging on for all of the systems, or I want to turn logging off for all of the systems. Now, I could just go in column select and type in on or off, but then I lose the state I have here. So this state is kind of important, because as I'm working on the project, I have, very specific systems that I usually want to be paying attention to. So in order to be able to override these flags, this variable right here, when this variable is negative, right, no one is silenced, so everything is logging, right? And then if I set this to +1, everyone is silenced, right? So, yes, I am using Notepad++. No, I do not know who the author of Notepad++ is. Hold on. You could make that state a parsed file, maybe. So you can swap quickly between... Yeah, totally. Like, that sounds That actually does sound like a great idea. It's like one of those things where it's like, you got, you know those like, here, let's throw that in there. Click on about. Okay, I will do that just in a second here. So, so when I do find interesting feedback from people, I will put you in the comments of my source code so that I know like that is a good idea. So I will keep that as a little reminder from you for next time I'm looking at this stuff and I'm like, hey, what am I doing? I will remember that this would be a cool feature for the future. So having a configuration file for that. Okay, so let's go look at the about. So let's see, question mark and about Notepad++. And let's see, can we make this a little bit bigger? Okay, let's see, about Notepad++ team. I'll click on that homepage. Blah, blah, blah. Distribute without warranty. Blah, blah, blah. You should have reviewed. Okay. Well, let's go look at the Notepad++ team here. And check that out for a second. I may have a very old version of Notepad++. Here, let's go search for that. Notepad++ contribute. Actually, hold on. This is, let's do this in Torch browser. Go to the, okay, yeah, I got it. Okay, yeah. So, let's go look this up. All right. Aha! Oh, I see. Oh, is that just... Whoa, hold... Is that just you? Is that only you? Because I've been using this for... I have been using this for 15 years. Yeah, I've been using Notepad++ for about 15 years. So... Hold on. So I have... so I've been using this for 15 years. So... Oh, why am I answering chat? I'll answer that for a second. I started using this when I started school at DigiPen. Yeah. So it's the... I like to keep things very simple. So Sublime is like a little bit slicker and fancier looking, but it's a little bit too much for me. And I am a you probably noticed I'm kind of I'm trying not to swear on my stream. Like, you can say whatever you want, but I'm trying not to swear, because I think the rules state that, you know, I can't say stuff, but I don't think I have to enforce that rule on you in order... I don't know how that rule works, but I'm trying to be family-friendly here. But, yeah, anyways. So, you were asking why I was answering over here, right? So, well, I know it was over... Where was... Oh, yeah, why am I answering chat? Because I want you to be able to see what I see, right? So, I want this stream to very much be... If I'm seeing it, you're seeing it, right? That's kind of how I want this to go. And also, I want the stream to be very much like a documentation kind of thing, where, like, you notice that, you know, most of the screen is just for code. I want to be able to sometimes go back to old streams to figure out what the heck I was thinking at certain times. So that's kind of why I'm answering in putting the chat down there, right? So obviously you can read it if I'm typing it, but... The idea is just now if you say something that I think is kind of like edgy or might get you canceled or something like that, then I'll keep it up. I'll keep it up there because I'm not trying to get anyone in trouble, right? So if you say anything that's kind of like controversial, I won't put it on screen, right? If I think something's slightly controversial, I'm not gonna try to F anyone over here. So. You're free to speak your mind, and I won't try to out you if you say anything batshit crazy. Okay, so TowSync. So I am doing a lot of very, like, stupid kind of refactoring, where it's like, you know, why not just make some type of system that kind of auto-generates this code, because I have it in every single system. And the reason that I am doing this in kind of a painstakingly stupid kind of way is just for the code readability. So there's this trade-off between the rigidity of the code and the... So I think more rigid code is easier to read, and more flexible code is obviously easier to change, but it's harder to read, if that makes sense. And that's obviously a very opinionated statement, but that's kind of like what I believe to be the case. So we have 2 more systems to stub in, and then once we get that going, I can actually show you where I am, because I have like the mouse wheel and the mouse kind of working in the editor right now, but you caught me at a kind of a bad time where I'm just kind of like refactoring stuff, so I apologize. But yeah, I just got this PAINT5D system and the PAINT5D OpenGL shader system, and then I'm good to actually show you what I got. I'm actually curious about that as well. I'm actually curious about this as well, Don. Because of the dinner table conversation I had last night. Okay, so let's go open up the PAINT5D system for a second. And we got some nice little shiny diagrams for the data layout, and this is the wrong thing. So that's the data file. I actually want the function file. So I organize everything in terms of a function file and a data file. So functions depend on data, but data does not depend on functions. That's the way I code. So rather than like a header file and an implementation file, I do data file and function file. And so far that's been working out for this project. Okay, so let's see. Halt function, status messages. We got an OK message here. So we're just going to go in here, and we're going to add this kind of logging function that we do for everything. And this is going to be PAINT5D. Lowercase namespaces are for private functions, and then uppercase are for public functions. I don't actually have such a thing as... I mean, it's C code, right? So there's not really public and private. There's like a... static, right? But there's not really public and private. But it's public and private on the honor system, right? So if you're using something with a lowercase namespace here, you better know what you're doing with it, is the idea, right? And also, right, with something that is private, the contract of that function may be changed in the future, right? So it's less stable. Okay, so PAINT5D, log, PAINT5D, make sure that it's all there. Token highlighting is like my thing. Token highlighting is awesome. Because I can not use crazy fruit salad syntax highlighting, and I can just focus on what I want to focus on, and I like that. So this right here, we're going to just make this a wrapper for this, right? So we're going to gut this function. Right, so at one point in time, I made all these different logging functions, like, oh, we got an OK message, and then we have, like, a goal message, and then we have an info message, and then we have, like, all these different types of logging messages, and eventually I was like, screw this is too granular, and I decided I only need 2 kinds of messages. I need a message when I crash, and then I need a message when I don't crash, right? So a fatal and non-fatal logging message. I only need 2. Everything else is a little bit too granular. So info any message, and we can, wrap this, right? So we can say that, that it's coming from here, right? ... And then we just say this message right here, it's already a const char, so we're good there. We can just throw that in there like that. And I like to, you might see me kind of peppering double semicolons around code in a lot of places. A double semicolon to me just means that the statement began and ended on, the statement spans more than one line if there's a double semicolon at the end of it. which is just a little odd redundancy I do in my code, because I'm very paranoid that I'm going to accidentally delete things, like accidentally delete a line in my code, not realize what I'm doing, Control Z too many times, not know how to use my version control, and just mess up my life. So I add a lot of weird redundancies in my code so that I can find mistakes easily, if that makes sense. Okay, so this was... okay, one more system, so let's just go... well, actually, let's make sure this still compiles before we refactor the last system. And then I will comment out... I could probably comment out one of the unit tests, and that might work for me. Discarded qualifiers, because... why? Hold on. Format string... Message okay, discarded qualifier. I thought this was still... oh, this is not... yeah, okay, got it. So we'll just make that a void pointer. And we should be good there. Also, you know what, if you know, I know I'm kind of doing some boring stuff right now, but if no one's seen my technical demos, and you're here, and you want to take a look at kind of the weird kind of stuff I'm working on, and kind of like where I'm trying to go, you can look at this, and you can get an idea of the kind of stuff I do, and that can be there to entertain you. If you have not already seen that, like, I don't know who's here. So... Let's go look for this. Really? What the heck? Oh, I see. Ew. Ugly. Info any was already here. We're gonna gut this out of here. Oh, hold on. 67. Where's the other one? Oh, go backwards. This is in 37. Okay, yeah. I thought I was out of the woods here. So we're deleting this because we are using a more update version. And this is what I'm talking about, my logging message is getting out of hand, right? We got an info message, we got an info message with a decimal override. We got some info message VPC, which I don't even remember what VP stands for. We got another info message for, oh, VPC, viewport canvas. We got a canvas or client, whatever you want to call it. Viewport 0 is the destination viewport. Viewport 1 is the off-screen memory buffer. So we got like a proliferation of logging messages, and that's... okay. Well, if we have all these logging messages, we're going to have to take another approach here. Log after halt. So in here, we're going to have to do... we have like a... is system allowed to speak? That's probably not exactly what the shortcut is. I'm going to go look for that really quick. So I have a big file of shortcuts, right? And I'm just going to paste this here because I don't know what it's called. And I'm sure there's probably like an allowed to speak somewhere in here. Yeah, so this is what I want. And are we allowed to speak? A watts. Okay, I could say a watts. And so I'm going to paste that here so I have this as a shortcut now. I have to reload that for that to work, though. But yeah, we're just going to say a watts, and then we have the snippet for is the system allowed to speak, and then we have lower and upper, and we're just going to call this PAINT5D, and then over here we're going to call this one PAINT5D here. So we got PAINT5D, we got PAINT5D, and the reason we need this is because it's just going to make it easier to refactor some of these non-standard logging functions in a more painless way, right? Because then we can just say if, you know, allowed to speak, right? If the system's allowed to speak, then we will do this stuff, right? And then we'll change the formatting a little bit. And then we can do that over here, right? So we can keep on doing that. And then we're going to clean up the formatting where we have this kind of wonky formatting. We're going to clean that up a bit, right? So right here, so if allowed to speak, then we do this stuff in here. Safety double flush. Let's just call that double flush. So at double flush. Now, if I'm in here, I do want to make sure that those little at symbols are for documentation. So sometimes I want to offboard my documentation to another file. So in here, there better be a thing called double flush, and if there's not, safety double flush. This is where I made that commentary. So we'll just say, you know, at double flush, right? Or at double flush. So double flush. In case printf parameters cause segfault, have a basic print and flush before your real call to printf, right? So very hackish, poor man's debugging kind of thing going on. That's just the way I do it because I'm a filthy casual and I don't know how to debug. Like I've used WinDebug very minimally, and the only reason I've ever used WinDebug was to look at the peb file so that I could do a peb walk and grab the function pointers to load library and get proc address from kernel32.dll without ever having to include windows.h. So I actually, my code, I'm using native Windows 32 code, but I don't actually include windows.h. So I have like one line of assembly to get the address of the peb file, and then I have like a whole bunch of helper functions, because I don't know assembly that well, right? I barely know assembly, so I just like wrote one line of assembly to get the base address of the peb file, and then I just made some helper functions to manually walk data structures using all of the offsets from the base addresses of the different structs. And I will tell you that when you write code like that, you realize that you thought you were a badass and you understood like pointers and dereferencing and all that stuff. Yeah, and then you write code like that, and then you question everything you know about dereferencing. Anyways, so yeah, allowed to speak, and then this is also an info message, so we're going to wrap all of this, right? So we're just going to wrap all of that in this like safety guard here. Right? And then we have one more thing, and then we're oh no, two more things, my bad. Yep. And then over here. Okay. And also indent. Indenting would be good. Yeah. And okay. So that's good. That's good. That's good enough for me. Well, I do have a logging function for binary printf. No, because this is for when things go wrong in my unit tests. I print off certain values as binary, because there is there's a lot of bit packing heavy stuff going on. So I made just a little helper utility function for that. Okay, let's just get this. Let's see if we have that refactored correctly. In my litmus test for that is, does it compile, right? So, and if yeah, that is a mistake. So cutting and pasting, and I've screwed myself over here. So let's just go look for if, and I'm sure that we've made that mistake in multiple places. So let's make sure that that is syntactically correct, and then look for this again. Oh, never mind, only in one place. Okay. So I have like the mouse and keyboard working for the editor, and the editor is nicely centered. And okay, so let's what are we gonna do here? We could just turn off the unit test for this for now. That might be the easiest way. to show you what I have, and then I'm just going to keep on doing my thing. So I'll get to the interesting part, and then let's just close. Actually, one more thing. PAINT5D system. I don't want to leave this half refactored. So one more system to add that refactoring for the logging, and then I will show you the actual code, the actual like in-game kind of stuff here. So in retrospect, I regret making a system called PAINT5D 10GL, not because the name is just batshit insane, but that PAINT5D and PAINT5D 10GL, they're actually the same system, really. But this is controlling the CPU side code, and this is controlling the OpenGL code, right? So CPU side, GPU side. I think it's much better just to make one system, and then if you really need a separation between GPU and CPU, just make 2 different includes and just break up the file into multiple parts. But oh well, this is the way I did it. It's too late now. Well, I mean, it's not too late. I could refactor it, but I really don't want to, right? Sometimes you just dig yourself into holes, and you just want to lay there and die. So, okay, so this info any message is already here, so we can just kind of go here and just say info any paste, and unfortunately the indentation is a little bit different, so it's not going to be as straightforward as usual, because I want to so I have this OCD don't go over the column limit kind of thing with my code, if that hasn't been already obvious. So we're gonna say like define logsys as AAC 2020 silence, because technically it's like it's more of a logging manager. Let's not mince words here though. Let's just call it logsys, and then let's just throw that in there to make that a little bit shorter. Go down here and undef logsys. Okay, align that nicely. So over here, let's change these cases here, and then we'll do some more stuff. So this is P5D 1OGL, and that's a mouthful. P5D 1OGL, and also it doesn't help that the O and 0 key are right next to each other. I should have never learned to say. What do you call it? I don't know who gave me the habit of, like, saying O when I mean 0, but that leads to me making bugs in my code, because I say O when I mean 0, and then I type O when I mean to type 0, and it doesn't help that they're next to each other on the keyboard, so it's like... why? So this right here... we're going to need to shorten this as well. So for that, we can just say f_f, and then up here, we're just going to say define f_f, and we'll just make it a flush command. We'll remove that semicolon. We'll shift this over a little bit so it looks nicer. And change the order here. So printf, and then undef flushf, right? So we're just flushing the console. Because I want to make absolutely sure that I see a logging message before I crash, so... Okay, so 1, 2, and 3, and then over here, little checksums. What time is it? 1:42. Okay. Okay, so that looks good to me. Now the next thing is just to give that a run, make sure that compiles, and then possibly comment out the what do you call it? I don't actually remember what you were responding to, because I didn't look at it soon enough. Oh god, I can't even spell. P-O-I-R-I-E-R. There we go, we can select that. I'm just curious. I knew two people who spoke French in college. One of them was Lebanese, because I guess their education system in Lebanon is French for some reason. So she spoke Arabic and French and then English, which, holy crap, like knowing 3 languages, like what the hell? Like how? How do you do that? And then I knew a French guy as well, from school. Okay, so let's just comment out the unit test for now, in Tau type, to show you like what I have, because I'm pretty sure I didn't break the code, but well, if I say I'm pretty sure that I didn't break the code, but it's broken. So in our functions, let's just go find the initializer. So we have our logging function, we have an init none function. So you might think this is kind of weird, but all of my systems either have an init function or an init none function. And init none function means there's really no setup code for the system, right? It's just like the system itself is really just a collection of functions. There's no data that needs to be initialized, right? That could also mean that there's a whole bunch of data, but it's statically initialized. There's no code that needs to be ran on it, right? And the reason for having an init none function and an init function, depending on which system it is because I like to be explicit about what I do, but I also like to be explicit about what I don't do. So if you ever heard that joke there's a joke that people that there's a corny joke that like high school or middle school teachers will say, where they'll say like, raise your hand if you're not here, right? And obviously you can't raise your hand if you're not there, right? However, in your code, you can actually do things like that, right? So this init none function is kind of the equivalent of saying raise your hand if you're not here, and it's just so that when I'm initializing all of my systems, I initialize them all in a very particular order. And so when I'm looking at the code that's initializing, that's calling all of the initializers, it's kind of like a roll call where I can see that like every single thing is on my list, everything is accounted for, right? And the other reason for naming it init none is because there might be a time at which I search for init and I don't find this, right? But I find init none. So I named it very specifically init none so that if you're trying to search through the code and you look for this init function, you can't find it, but you find this, right? So maybe not the function you were looking for, but the function you needed, right? So I want to write my code in a way that facilitates people being able to look through it, right? So I know that a lot of my code looks completely insane, but I am actually trying to write it in a way that makes it easy to navigate and search through. So we're just going to take this call to the unit test and just comment it out for now. And then we're also going to, because that's kind of a dangerous act, we're going to say AAC 2020 to-do manager, to-do man, vital, put the unit test back. Okay, so what this is for is I have a macro for my to-do messages, and I have a macro that will make my code crash if there's any vital to-do messages. So there's 2 categories of to-do messages. I have vital to-dos. They are to-dos that I absolutely must do. And then there's maybe messages, so things that I might want to do. So nice to haves, right? So when you have feature creep kind of things get a maybe to-do message, and then absolute requirements get a vital to-do message. So this is a vital to-do because it is absolutely imperative that I comment this back, and I don't want to lose track of this, so I'll put this in here, and we will eventually find this mistake in the future if we forget to put this back. So let's give this a run and see we'll see. We'll see if we can actually see what's going on here. I'm fairly certain that we'll actually get the graphics up now. Okay, so let's go over to, let me show you some of the other stuff first, right? Because I don't think you've seen this. So over here is my little memory viewer. So instead of using uniforms, I use a big texture. And that texture is partitioned so that different, oh god, I'm losing my bitrate. So different systems get different. Yeah, so different sections of the texture are reserved for different systems, and you're seeing kind of all of the pixels that are storing different data for the current system, right? So this is a 32 by 32 chunk of pixels on a 512 by 512 texture, and this particular 32 by 32 section is for this particular 32 by 32 section is for the PAINT5D system. Now, I have some problem with my Win32 code, so I have to stop this and rerun it to show you the other stuff. And then I'm sorry that my bitrate kind of sucks here, so you can't really, I'm probably, I'm dropping 36% of my frames. Ether, cable, and hard. Yeah, so the cable modem the cable modem is no longer in the basement, and that has screwed me over. So anyways, let's do P for pattern, load a pattern here, go through the different layers. So there are 16 auto tile sets, right? So we have 16 different auto tile sets here. Some of this is blank, just because the pattern that is loaded in here, the data that's loaded in here was meticulously handcrafted in Paint. And it's not completely conforming to, it's not completely well structured, right? Basically, I painted something in the most significant bits of the red channel to get this thing here, and then right here is the most significant bits of the blue channel that I painted another pattern, right? So every single pattern you're seeing uses 2 bits of a pixel, right? So there's 32 bits in a pixel, right? And so I chop up the pixels so that I can get 16 different layers. And so that's how I'm creating 16 different auto tile sets from one 512 by 512 image. So let's show you what I have so far. So right now I can use the mouse to kind of zoom in and zoom out, and it always zooms in by 1 pixel. So it might look like the zoom is speeding up as we get closer in, but that's not the case. The zoom is completely linear. And then we can actually change the tile colors here, right? So I can set this down here, and you can see how that got a little bit darker. And I really actually don't remember what the keyboard shortcut for changing the tile size was. So let's go look for that really quick. Actually, let's go down here for a second and go to something that's more blank. So let's go down to this here. And so, right, so we have these tile sizes. And then where is... I don't even remember. I gotta go look at the shortcut. So I'm gonna go look at my key bindings. So my key binding data, I'll go find what that is. I don't remember what it is. Left, right, up and down, auto tile sets, patterns, tile value, toggle, okay, tile size exponents. So if we go look at what that is, okay, so W and X for going up and down. Okay, so I'm gonna have to rerun, yeah, my window code, I don't know what it is with the window code, but if I do not do anything in the window for a while, it crashes. And the weird thing is that I can press Control-Alt-Delete, and then the program will work again. without doing anything else. Just Control-Alt-Delete will fix it. So I think that I'm like collecting messages in my message queue, and they're slowly building up over time or something. Like something about moving the mouse is draining the message queue, and then when the window isn't in focus, the message queue is getting overflown. And then Control-Alt-Delete, I'm guessing, dumps out the message queue, and that's why Control-Alt-Delete itself just fixes the unresponsive program. I think that's what's going on. I could be wrong. So W and X was the thing right here. So actually, let's not even worry about W and X, because we just want to paint, right? So here... Oh, oops. Ah, God damn it. So I need to cap my brush size, because I used the shortcut to make my brush size bigger, and then it went out of bounds. Okay, so next time, X key. Okay, so let's go over here. Click, clickety-click, 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 right? And we can draw some stuff. We can zoom in a little bit if we want, but let's not worry about zooming in. Let's just make this, right? So we can do this, make some stuffs. Right, so we have these different kind of pixel sizes, right? Right, the idea is that it's basically, right now, the tile editor is basically like MS Paint, but you have all these different pixel sizes, right? And then you can overlay these different sizes, right? So we can see these little tiny pixel sizes and these big gigantic pixel sizes, and then we can overlay it. And obviously, this needs a little bit more work to make it more friendly to work with, because right now, the zooming needs some type of weight applied to it, because the zooming is kind of painful. The tile colors, I don't remember what the brush colors are. So W and X, maybe Q might give me something different. Let's do W, make this a little bit bigger. So maybe it was Q. Yeah, so there we go. We got some different colors, right? Different colors. We can make some designs, and we can overlay these. And then let's go to the next tile size up, right? So next tile size up, blah, blah, blah. Next tile size up after that. Next tile size up after that. And I think it crashed after I went to the highest tile size. Okay, nope. Oh, it crashed after I clicked. What the heck? I'll have to figure that out. But yeah, so the idea behind this. So let me open it up one more time and show you one of the patterns I've already designed to show you like okay, what is the whole point of that anyways, right? Like why do that? And so let's just go over here for a second and do P for pattern, load a pattern in here, and look at this. So this is an auto tile set. And usually I call an auto tile set an offset in my code. I just abbreviate it so that I can, yeah, boom, everything exploded on me, yes. Yes, you are correct. So, oh god, where are you? Sorry. So over here, what we have is, this is the top left corner, this is the top right corner, this is the bottom right corner, and this is the bottom left corner. So an auto tile set is, the auto tile set scheme I'm using is known as wing tiles. So there's like a GPU gems paper on it. If you've done auto tiles, you probably already are familiar with this, but it's 16 sub-tiles per tile set, and you create a bit mask of 4 bits, right? 4 bits is the value 0 to 15. And that bit mask tells us if we have a neighbor to our left, a neighbor to our right, a neighbor above, and a neighbor below, right? So we have a bit mask that tells us who our neighbors are, and depending on who our neighbors are, we select the correct subtile of the auto tile set. So if I, let me try wing tiles. Wing tiles. Not a shortcut? Well, I'm going to make that a shortcut if it's not. Oh, no, it is. Just took a while to load for some reason. So that'll give kind of information on what I'm talking about. Now, if you want kind of less information-dense explanation, auto tiles explained. That'll give you a little less dense explanation of what I'm talking about. in terms of auto tiles. And also, I can go to my technical demos as well to explain auto tiles to you. So actually, let's go to the technical demos just so that I can explain what the heck is going on here for people who are not familiar with auto tiles. So let's just go to my demos page, and we're not going to look at everything. We're just going to look at one specific thing, which kind of well describes what an auto tile is. It's a little bit more crazy than a normal auto tile, but it explains pretty well. So right here, this is basically the auto tile code, right? So we have this one material, right? So you could think of an auto tile set as a material, right? These 16 subtiles create a material, right? A 2D material that is self-aware and latches together, right? Now, the thing with auto tiles is usually when you say auto tiles, people think you mean, you know, old school graphics, you know, old school 2D graphics. And yeah, that's a valid auto tile, but I think we can take auto tiles to a more advanced level, right? So I think that we could actually do auto tiles as fancy, crazy shader code, right? So that's what this kind of technical demo is here. So I got my little eraser, can erase some stuff. So I'm trying to make another game where we have a whole bunch of bombs and the geometry of the level can cleanly destruct. So what do I mean by cleanly destructing? Well, so I know I'm ranting here. Ripped in half with chainsaw. There's no way this is a shortcut, but we're gonna find out. No. So I'm gonna go look for this for a second. So in here, I'm gonna make a shortcut called ripped in half with chainsaw, so that next time bash scripts. Next time I look for this, I'll be able to find it. So ripped in half with chainsaw. Okay, so I gotta go find that URL for a second. And I know that chainsaw will probably find what I'm looking for, so I'm gonna go search through my shortcuts and see if I can find that. Tiger chainsaw, no, that's not what I'm looking for. Come on, did I really do this? Okay, let me go look for Doom, right? Doom, because it was from the Doom Eternal, or maybe it was just the Doom, Dr. Strangelove, no. Nope. Doom cut in half, this thing. Okay, I'm gonna take this. Don't cancel me if you see anything in here that is, politically inflammatory. Okay, so anyways, we'll put that in there for next time. And also, do we have a shortcut for chainsaw? So for next time, we can at least find... No, we don't. So next time I am searching for this, I want to be able to find... also, sorry. Okay, so next time I want to find this shortcut. It'd be nice to have chainsaw kind of, like, lead to things, right? So, we want to say try chainsaw Doom, or try chainsaw Tiger, right? So, Tiger chainsaw from Family Guy, just because I find it hilarious. And then we can put this here and say chainsaw Doom and chainsaw Doom, right? And then chainsaw Doom as well. Have all these kind of shortcuts here. And then let's go find chainsaw Tiger. I'm going to guess this isn't a shortcut yet. Okay, so let's go look for chainsaw. Because we know that down here at a later time, yeah, we have this chainsaw Tiger. So we're going to say chainsaw Tiger, or chainsaw Tiger, or chainsaw Tiger, right? So next time I want to find this, right? In like 5 years, if I forget what these shortcuts are, I'll be able to find them, right? Okay. So let's go over this for a second and explain what the heck I'm talking about with cleanly self-destructing, right? Oh, come on. Okay, let's just kind of reverse here for a bit. Okay. Okay, right here. Okay, right? So, you got this model, right? You got this model, and you cut it in half, right? Well, an artist had to specify the geometry in here, right? The internal geometry had to be somehow specified, right? So when you're thinking about destroying a tile map, when you have a two-dimensional level that's made with a whole bunch of different tile values, you want a way for that to... If you're going to blow up a section of the level, you want to somehow expose internal details, or at least make it kind of cleanly self-destruct, or cleanly break. What do I mean by cleanly? Because cleanly, I don't really mean it in the conventional sense. What I mean here is, instead of... When they cut this in half, it's not like, oh, there's just one big flat polygon with a flat color here, and one big flat polygon with one color here, right? They actually put some effort into, okay, if we break this in half, if we break this model in half, what do we want to see on the inside, right? So we want kind of a similar idea of, like, how do we create the level in such a way that... we want to create the level in such a way that when we... let's say we have a wall. If we have a wall, and we want to delete part of the wall, we don't want it to look like someone just went into MS Paint and used the eraser on some pixels, right? We want it to actually, want it to look nice when the geometry is destroyed, right? So the first step to making things kind of like procedurally self-destruct in a way that is pleasing to the eye, in a way that looks professional, is to use auto tiles, right? So an auto tile system is the key to getting kind of like this self-destructing geometry where things kind of like look much more plausible, right? So like if we're like blowing a hole in, like if we're tunneling through this, whatever this stuff is, right? Right? It doesn't look like I'm going into here with an eraser tool, right? Like everything is kind of latching together nicely, and therefore... I don't know, the aesthetics are important, right? Like, if we want, I'm trying to write a rendering engine, so the way I go about things needs to look professional. It needs to look quality, right? But yeah, so if we're going to make a game that revolves around having explosives that can basically take out any part of the level, we need to really think about the rendering system and how the rendering system handles the latching together of materials and the blending together of different materials and all that kind of stuff. And so that's kind of what this is about. So also, to take that to a little bit of a higher level, besides just auto-tiling, another thing we can do is we can make multi-layered tile maps and make different materials kind of blend together. So that's kind of what you have here. And not only that, but we also have rendering settings applied to this, right? So this rendering engine I made in ActionScript, right, is a multi-layered tile map, and there's 3 different rendering settings applied to this, right? So this is foggy morning, this is sunset, and this is starry night. So, but anyways, there's some other stuff in here, but that's really just the important stuff for here. Okay, so I'm going to get back to just kind of like doing my debugging kind of stuff, doing my boring debuggy kind of stuff. So, and also it's like at 3 I have to go anyways. So, I mean, you can stick around if you want to stick around, but it's not gonna be interesting as far as I'm concerned. So yeah, that was the interesting stuff. So I'm going to put my unit test code back in here so that I can get to the process of figuring out what I have blown up. Also, you might notice that I have a forward declaration right before I call this. That's because most of the time I write my code without forward declarations, and then when I a forward declaration right above the call is a contract in my code that says this function here is lower down in the code, right? And then if there's no forward declaration when you see a call to a function, that means the function is higher up in the code, right? So I don't have to... When I'm trying to look for where a function declaration is, I know which direction to start looking. So I do a lot of things in a very old school kind of fashion here. So, yeah. Okay, so let's close this. We're done with this, I believe, right? We're done with this? Yeah, we're done with this for now. We're done with this uniform stuff. We're done with this. Do I reload that? Yes. We have too many things open. Okay, let's try to get this down to... Let's try to get this down to just 2 editors. Right. So, boom, over there. Okay, so yeah, let's see, refactor, this is, yeah, that's done. So, we're gonna take this to-do here, and we're gonna go open up our done file, right? So we have a done, and we're just gonna throw this in here and make a date for it. So, the date is 2021-02-25, and we're just gonna put this in our big text file of things that we have already done. So, so, put this in here. And then I guess to make it completely... Okay, well that doesn't quite work for me. Okay, yeah. So yeah, that is done, so we'll put that there. Yeah, we can make a note of the video ID, right? So it's video ID 157, and the time is 2 hours, 2 minutes, and let's just say 42 seconds to be one of the cool kids. Done at this time, right? So yeah, that's the time at which we completed this, and we can also say the date as well, if we really want to be meticulous about this. Oh, well, we already have the date around there, so I don't really think that matters, right? Because the section is partitioned by the date. Do I reload it? Yeah, sure. Okay, so we have this EnforceBounds function, which is meant to adjust our we have a rectangle type, and the rectangle type is mostly used right now for camera controls. And when the camera gets too big and tries to go outside of the bounds of the data, or you could say, if the camera goes outside of the level, we want to shrink the camera down so that it can't go outside the level. So we want a maximum zoom, right? We don't, the way I've designed the camera is that I do not want the camera to ever go outside of the bounds of the data that the camera is looking over, right? So if the camera is kind of like sub-selecting over a tile map to render that tile map to create like side-scrolling action. If we're side-scrolling and eventually we get to the end of the level, I don't want the camera to go outside of those bounds. So the EnforceBounds function has code that just gracefully resizes the rectangles. So we made some changes to it. And we want to make sure those changes do not wreck our unit tests. And so we realized that this new change here shrinks our rectangle before it shifts it around. So because the rectangle is an inclusive rectangle that has a lower and upper x bound and a lower and upper y bound, to move the rectangle around and to shrink and squash it in a way that it thinks it has a center, we have to be very careful about how we adjust the rectangle when we're fixing it up. So the first thing is, if the rectangle is too big on the x-axis, we want to... oh, actually, no. This is for if we shrink the rectangle so much that the points invert on themselves, we will just want to swap the order of the rectangle points. And then over here, if the rectangle is too large, right? If the rectangle is too large on the width axis or the height axis, we want to pull in both edges by the same amount, right? Right here and here. For the x-axis, if the x-axis is too large, you pull in like this. If the y-axis is too large, you pull in like this. The reason for that is because we want the camera to behave. We want the camera rectangle to behave as if it has a center point. So if we shrink the camera or grow the camera rectangle, we want it to do so in a way where it thinks it has a center. So that's why we have the logic as such, right? And so before we start trying to translate the camera, we want to shrink the camera so that it fits within the bounds of the space provided to it by this rectangle bounds variable, right? And then after that, if the rectangle is still outside of the bounds of the data, then we want to either, you know, shift it over to the right, or shift it downwards, or maybe we want to shift it over to the left, or maybe we want to shift it upwards, right? But when we shift it over to the right or left or up or down, we want to increment both borders. So x0 is the minimum border, and then x1 is the maximum border. So the left border and the right border, and we shift it over by the same amount, right? So these functions manipulate the rectangle so it behaves as if it's a rectangle rather than a collection of borders, right? Because the data structure itself is really a collection of borders, because that data structure just makes it a lot easier for me to work with. So, okay, so we commented out, where are we? So actually, we didn't comment this out. So this fix is happening, remove me. So I just wanted to be notified of if this case was happening. And I'm fairly certain that this code won't have any negative impacts on my unit tests, but we've mucked around in this code a lot, so there is the potential for some type of catastrophic issue where there is a potential that this code could wreck our unit tests. So I wanted to have this message here just to give me a heads up before I have to revisit my unit test logic and figure out, are my unit tests broken? Okay, if my unit tests crash, is it because the code is now wrong, or is it because the unit tests are now wrong, right? So we have more insight. We had further insight as to how those rectangles should behave. And so the old unit test code may have an outdated model of how things are supposed to behave, right? And so because of that, we may find that some of these unit tests are going to fail on us, and we're going to have to figure out why that is, right? So, so right here, test index 16, we see that something's going wrong, and we need to know why that is and what to do about it. So let's go look at that. And I'm thinking that this was probably supposed to be 0 and 511, I'm guessing. So let's go look for test index TI. And this probably exists in more than one place. Yes, it does. So in order to just make this easier to find in the code, we're just gonna do like just gonna put a little face here. I'm gonna do a little face here, and then in the other code where there's a test index, I'm gonna make a different face, right? So I'm gonna make a little face like this, and then I'm also gonna do PF for printf. Okay, and then, right, so now we see, we're going through this code, we can see the two different faces, right? Boop, 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 boop. So we can more easily know which code is failing us. And then we did PF for printf, so we have all this test code. We're gonna go and add a macro for printf, right? So we got all these different macros. And unit test. That's kind of a weird way to do our stuff there. We'll do printf, I guess, makes the most sense right here. So define pf as printf. And paste this here, then do 10. And yeah, so pf is right after the UO8. So let's go down to here. And it's right after the UO8, so we're going to go in here and just go undef pf. Right, and hopefully we don't destroy anything. We might need some refactoring after this, but we'll see what happens. Okay. So we're going to give this another run, and it's going to crash on the same place, but then in the logs we'll be able to see kind of where that's coming from. Okay. So we got this little XE face right here. So now we know where that's coming from. So let's go find that. Yeah, so right here, we see it's test index 16, right? So we can go up to the test table, right? And we can find test index 16 and go, what's up with you, test index 16? Why are you screwing me over? And we see test index 16, and we see this 0, 1, 2, 3, 4. And I get the idea, where the idea was that, you know, if we're out of bounds, we want to snap to something that's like hold on here. Oh yeah, this is 16. If we're out of bounds, hold up. Am I check something wrong here? Hold on here. Test index 16. This is not the expected values, is this? Our expected values here are 0. We're expecting the... Okay, hold up here. Did we accidentally go too far? Test index. TI. Expected and actual. So the actual... Oh, we expected all zeros and we didn't get all zeros. Okay, never mind. So the question is, like, why are we not getting all zeros, right? We're expecting all zeros for some reason. So in 16, we're expecting all zeros. This is a translation. What is this? This is a zoom. Okay, so we're zooming. I have no clue why that would be all zeros. Oh, because we're zooming in. We're zooming in by a very drastic amount, and therefore that would end up as 0, right? Because we're here, and then we're zooming in, right? And the EnforceBounds is... Got it. So if something... Okay, got it. I see. So So if it's a bad order, we don't want to swap. If it's a bad order, we want to bring it in until it's the correct size. So, and I mean, some of this code probably already does that, but let's just try to get it to behave properly, right? So, yeah, we don't just want to swap it. We want to, if it's in the wrong order, we want to figure out where that center point is. So, um, converge on bad order. So really what we want to do is, if the rectangle is inverted, then that means that we zoomed in too far and the points just got swapped because we zoomed in so far, right? So we actually want to converge on a bad order. And for that to happen, it's video 157. And yeah, so over here, we're just going to make a note of when we came in here. And yeah, oh, that's not quite correct, is that? We're just making a note of when we came in here in this video. We don't want to do this. If these points are out of order, then we don't want to swap them. We want to know how far apart they are. And we want to bring them in, right? So we want to bring them in by enough to where they're either tangent next to each other or they're collinear, not collinear, concentric. So we want to say like let's say int32 distance x equals so remember the x1 is less than, right? So it's x0 is the greater one in this case. So x0 I32 minus x1 I32 plus 1, right? So let's just say dx for distance x. So it's the distance slash length on the x-axis, right? And it's the larger value, right? Because this is less than, so larger value minus the smaller value, right? And then same thing for the y, right? So let's steal this. And for this is going to be dy. And this is going to be the larger value minus the smaller value, right? Because these are flipped around. And once we have that, we got to think about visualizing this correctly. So if we have... So if we have this, so here's our even case. So this is our even case. We'll call this case EV for even. This is the even case. And then we have an odd case, right? So the odd case is where we have odd. And let's just say it's this, OD. Or let's call it O for odd. even case and odd case. And let's just say that, you know, we have something, points B and A, right? B and A, and they're out of order, right? So, right, B and A, where B equals out of order max point, A equals out of order min point, right? So we have an out of order max point and out of order min point, right? B and A. And yes, we have these out of order points, and we want to fix them, right? So how do we fix this? How do we make this proper, right? We want to get over here, right? So the distance, the length here is 4, right? So this is 4, right? The length. And so we want to just move this 1, 2 over, right? We want to move this one 1, 2 over, right? So the fix B plus dist or len divided by 2, right? So if we go here, we go 1, 2, right? We go 1, 2. We're over here. We go 1, 2. We're over here, right? So, right. So now A is here, and then B is here. So fixed, broken, right? So just the fix is in A is going to be minus len divided by 2. Okay. Now how about over here? What's the fix for this? Well, we go 1, 2, 1, 2. So we want this concentric, right? So we've got to go 1, right? So the fix here, if we're going to move 1, what's the fix? Well, the length right here, what's the length, right? What's the length for this? So the length here is 3, right? So if we take 3 and we divide it by 2, right, we get 1.5. So it seems to me that the length must be so the fix here is hold on, let's try to align that better. Or is that already aligned? Yeah, so the fix here is B plus trunk len divided by 2. Truncate. In integer division, we'll automatically truncate anyways. But we want to make sure that we do this correctly, right? So len divided by 2, right? So when we're thinking about this, we want to make sure that this... Now, if we didn't even consider this, we'd still have it right, because coincidentally, the integer math is just going to work out how we want it to be. But, right? So the idea here is that an inverted rectangle is the result of zooming in too far. And to fix it, we just want to put it back into the state, the minimum possible zoom before it had inverted, right? So that's why we're kind of like untangling that rectangle. So yeah, because this is going to go over 1, this is going to go over 1, so 3 divided by 2 is 1.5. Truncate that, we get 1, right? So this little proof of concept, or this little thought experiment for the minimum case, I'm going to take that and I'm going to roll with that and say that that will work for larger values as well. So I have no reason to think that this math is not going to like scale for other higher numbers, that like other values that are harder to reason about, the math is still going to be the same. So this is kind of like when you're trying to reason about things, use a very isolated, small case that you can reason about. Don't use, like, gigantic numbers that you can't actually fit in your head, right? Or you can't even, or gigantic numbers you can't even fit in an ASCII diagram, right? Okay, so that makes sense to me. So down here, when we want to do length, right? So this len div2, we're gonna do like I32 L2 or LD2. How about LD2, right? And equals dx divided by 2, right? And then we could just make a note here that LD2 equals trunk len divided by 2. Right, so when we're trying to figure out what LD2 is, that's what this is, right? And then over here, same thing. We're going to make an LD2 variable, I32 LD2, equals this length variable, dy is the length variable, and we're going to divide it by 2, right? Okay, so now that we have that, all we got to do is the x is the minimum value, right? x1 I32 plus equals LD2, right? And then the x0, x0 is too high, so LD2, right? So, pull it apart. We're going to untangle it by pulling it apart, right? And then over here, we're going to do the same thing, right? So, same deal. Just put this in here. And instead of x's, this is y's, right? We're in the y section. So, we got the x's here, and then we got the y's here, right? So, let's make sure this is correct, though. So, the y is too high, right? The y is too high, right? Because y is greater than the 1, right? So the lower is greater than the maximum. So this is too high, we got to pull it back, right? This is less, the maximum bound is less than the min bound right now, so this is too low, so we have to bring it forward, right? So minus plus 0, 1. 0, 1 minus plus. Okay, so all that logic makes sense. And then after we've done that, we want to make sure that this is still, that we've actually fixed it, right? So that's what that's for. Okay, so now let's kind of run our test and see if we can pass our unit test or not. So if we can pass our unit tests, then that'd be nice. If we don't, then we have to figure out, we got to figure out if our unit tests are like off by 1, right? So there is the possibility, well, oh, hey, cool, our unit test passed again. That is so nice. That is so nice that, because I was kind of scared there, because if you look at our unit tests, I mean, the whole point of our unit test is to make sure that we don't accidentally change functionality, right? So it's like, it's good that all these crazy unit tests and all this crazy stuff, right, we got the basic functionality back, but it is pretty intimidating, right? But you know what's more intimidating? Making big changes to your code, thinking you might have changed the functionality, but not having any unit tests to assure yourself that everything still functions the same, right? So it's like, okay, so I think we're good with that. So let's actually try to zoom in and out for a second. And then I actually do have to get going because it's like 2:37, and I think that I had to drive my mom to the hospital at like 3. She's not like dying or anything, but I do have to drive her because she can't drive herself right now. So okay, so we got this here. And now the question is, what happens if we zoom too far in? Will we actually get truncated here? Or does it still crash on us? Like, what's going to happen? I'm going to hope it just stops eventually. Nice. So it stops at the maximum possible zoom, right? And then we can go out, and if we go out, we're going to hope that it gets stopped at before we go too far, yeah. So there. So now our zooming isn't crashing on us because we're properly truncating, or not truncating, we're properly adjusting, we're properly fixing the camera rectangle. So when we send signals to change the rectangle to make it go out of bounds, we fix it, right? So that's good. Now, the reason we have code to fix the rectangle rather than never allowing us to break the rectangle in the first place is because that's just going to get the most easy to work with camera code in the future when we want to write some camera code for this kind of stuff here, right? So, so that's cool. Awesome. What do we got to do next? So the next thing is to get like a drag, right? So right now, or actually maybe we want to make this just go faster, right? So, I don't know exactly how we're gonna adjust this, but something needs to be done because I'm not feeling this. This doesn't feel right to me. I feel like, I don't know. I don't know what needs to be done. I feel like maybe it's like, we need like an inverse exponential, I think, right? So, at the outermost zoom, we want to like zoom in by, I want to zoom in by, say, halfway, right? So like if I click zoom, I want to zoom in pretty fast, right? Because right now it's just kind of like moving in. It's zooming linearly, but it might look like it's zooming exponentially because of just how perspective kind of works, right? So like if you are heading towards Earth at like, you know, 1,000,000 miles per hour, right? Or maybe not 1,000,000 miles per hour. Let's say like, you know, 50,000 miles per hour, right? You're heading towards Earth really fast in a spaceship, right? If you're really far away from Earth, Earth just almost doesn't even move at all, right? It doesn't even look like Earth is growing because you're like so far away from Earth, right? Even though you're going so fast, Earth is so far away that it doesn't look like the zoom that you're seeing doesn't really do much, right? But as you get closer and closer and closer and closer, the perspective shift starts to happen at a faster rate. So you can see that this is very quick, right? But I'm not actually doing any exponential change to my scrolling. This is a completely linear scroll. It's just that a completely linear scroll is just not very nice to work with, right? So we want to inverse linear scroll, right? So we want to be able to, when I do like one little notch here, I actually want to like go in like 50%, right? And the next notch I want to go in like 25% or something like that. I'll figure it out. But we want more friendly zooming behavior. So we might want to figure that out first. So if we go in our to-do list here, in our to-do list, we're going to say item number 4 is, well, actually, this is actually fixed. So we passed this. So let's go in our done folder. And we're just going to paste this in here. And this is number 4. And we'll make the date as well. So the date for this, we can just steal this date stamp because it's still the same day, right? So we're going to take this. Bam! So we got the state. And then let's go over our to-do here. And toggle tile should toggle a tile, but before we do that, we'll make this 6. 5. Make inverse exponential zoom because the zoom we currently have is painful to work with. We need a quick editing friendly zoom controls. So polish zoom, right? So we want to polish the mouse wheel zoom. And this toggle tile thing, before we do toggle tile, we want to make a different 6. We need non-primary click to drag / pan the canvas, right? So non-primary click equals right click, left, right, equals right click. So I say non-primary because I don't know my right from my left, and because right, my dominant hand is my right hand. Oh, thanks, yeah. So my dominant hand is my right hand, and so I don't know if anybody else does this, but yeah, I get right click and left click mixed up. I guess this is kind of a non sequitur, right? Hey, thanks. I get right click and left click mixed up. That makes no sense. But yeah, but I know what you're talking about. You were talking about the other stuff I was rendering, right? So it's going to get more cool. Like, I guarantee that things are going to get exponentially cooler as time kind of passes on. But it's gonna take time, right? Because I'm building up a very solid, sturdy foundation for this code base. So, you know, it's gonna take some time. But it's 2:44, so there's probably like 15 minutes before we have to leave, and I don't know if my mom forgot or whatnot. So I should probably just end the stream now, because I don't want to, like, accidentally miss her, like, hospital appointment or whatever. So this looks good. Let's just git commit this. Panning control. Let's just, yeah, panning control. So let's just edit this. Okay, 2D looks good. Let's go over here. So are you, I assume... So yeah, let's get this working. So let's, well, not get it working, but let's commit what we have. So git status and git add dot, holy crap. Git commit -am, silence, system refactoring, right? So that's basically what we did, right? There's some other stuff we did, but oh well. Too late now. We'll try to get better with our git commit messages. Git push GitHub master. Oh, alright, yeah, okay, cool. So that's what I thought, yeah. Okay, so I'm gonna get out of here. And actually, you know what? One more thing. Since it actually compiles correctly, I'm gonna go push this up to the public. So I'm gonna go push it up to the public repo. So git push kanji coder master. So if you want to take a look at that, if you want to take a look at this actual code, you can go look at my GitHub, my public GitHub. So I only push up the working commits, right? So sometimes things are in a state of brokenness and disrepair. So in that case, I don't make the commits to the public, right? You nugget? All right. And now, is that related to chicken nuggets? Like chicken nuggets? Okay, yeah. So I'm gonna get out of here because I don't want to miss that, right? And she said 3 o'clock was when we had to leave, so I'll figure out something to twiddle my thumbs with. I'll do like more push-ups or whatnot if we're not leaving right this instant. More. So, but yeah, I'm gonna get out of here. Let's see, what's our title screen? So we've been doing mouse wheel code. Well, the section we're in is mouse wheel, even though none of this really related to mouse wheel. But sometimes you break things and you have to like go off on like a side tangent, and that's kind of where we were. We're on a little side tangent. We are on mouse wheel stuff right now at the moment. So I will I'll see you around. I'll see you later. I have no clue when I'll be back, but I try to do this every day except for Sunday. So later. And also Monday is coffee day. So yeah. All right, later.